If you're into electronics like Arduino or building kits, here's three 3D printed tools that you want to check out. In fact, I'm going to test all three and figure out which one's the best right here at Filament Friday.
This video is sponsored by PCB.
I've been playing with electronics this week. I found this kit on Amazon. It's a roulette wheel using LEDs and some dip sockets. And then I got some red boards from PCB for my Chipino. So I wanted to assemble those. And both these require dip sockets. So I wanted to try out these 3D printed dip pin straighteners. When you're working with electronics, a lot of times you find two different integrated circuits, either a dip version or through hole device that you can actually remove from the socket. And then there's surface mount, which is soldered to the board and you can't change it unless you unsolder it. When you remove the dip or through hole device, the pins are already lined up with the socket. But if you use a new one that comes right out of the tube, those pins are flared out, so it won't line up with the socket when you try to install it. Like this here, I'm going to try to install a new one into this socket. It just will not line up. And this is where a pin straightener comes in. And there's different types and different designs that we're going to test today. So here's one where you just slide the chip or the integrated circuit through the pin straightener. And hopefully it's going to straighten out those pins. So it should look like this. Here's the before and here's the after. And here's the results. It's straight. It straightened the pins right out. So it did a good job. Now will it fit a socket? Yes. It lines up and we can push it right into the socket. So I found 3 pin straighteners on printables.com that I want to try out. 2 of them are spring-loaded, and 1 is just a mechanical slide like you just saw. Now, I've just built up a bunch of Chipino modules because I got some new boards from PCBWay.com. I got some red silkscreen, which I've been wanting to get for a while. So I ended up getting their 10 boards for $5 deal, and I love how these things look. You can go to PCBWay.com, just click on the $5 for 10 pieces, and it'll take you right to their PCB order page. There's also a Gerber viewer on there where you can upload your Gerber files to make sure everything looks right. And then after you've got this, you can go back and select the features that you want for your circuit board. The first thing I did was go to the quantity box and I selected 10 pieces. Then I scrolled down further, made sure I selected FR4 material, and then I chose red solder mask and white silkscreen. Solder mask covers all the copper traces and only leaves spots where you need to solder. Green is often the default, but PCBWay has a lot of different colors. I chose red. I chose a white silkscreen, which is all the lettering. You can go with different colors here as well. And the instant quote shows 10 boards for $5 plus shipping. PCBWay has a Christmas sale where you can get purple, matte black, and pink as a free upgrade. They're also offering clear 3D prints at a discount. So I suggest you check out PCBWay.com before this Christmas sale ends. Now back to the 3D printed pin straightener tools. I want to use it with this board you see, this green board, which is a kit I found on Amazon. This is a kit, it's a learn to solder kit, but it's a roulette wheel. I thought it might be fun for Christmas and it was only $9. It comes with a green solder mask circuit board with white silkscreen and all the components that I need to solder into the board. The silkscreen layout helps identify where the components go, and the schematic was shown on the Amazon listing, but unfortunately, that wasn't included with the kit. This is all that was included in my kit, a 2-sided sheet that showed the silkscreen layout and a finished board, which helps, but I don't recommend this for a beginner. The first thing I need to do is install the IC sockets. There's a 16-pin and an 8-pin, so I just lined it up to the picture, and now I'm going to use these pin straighteners to see if I can straighten the pins on these sockets because they got damaged in shipping. Now, unfortunately, not all these pin straighteners are designed to work with sockets as well. The first one I found on printables.com was from A3D Printing Farm. I downloaded it to Prusa Slicer, and I'm going to slice at a 0.2 layer height on the Prusa Core 1 at a 15% infill. It looked good. 12 minutes to print this. I'm using this generic gold PLA that I found on Amazon, and I love the results. This turned out really good. Next, I found this dip IC pin straightener on printables.com from user Slothie, and this thing can do both wide ICs and thin ICs. I brought that into Prusa Slicer, and it's actually 2 pieces. I printed at the same 0.2 layer height, 15% infill, and everything looked good here too. Pretty basic prints, really, and this one took 29 minutes. It's pretty easy to assemble. You take the centerpiece, slide it into the pin on one side of the holder, and then pull the holder out and then pop it into the other side. And now this thing's assembled, and now you can squeeze it because it's spring-loaded to pinch the pins together. The last one I'm going to try is the IC dip lead straightener from printables.com, user Phenex. And this one is one piece. You don't have to assemble it, and you squeeze it. It's spring-loaded. I printed at a 0.2, layer height 15% infill, same as the others. This looked fine as well, and this one only took 15 minutes. So it was small and fast. Now this one I could see a few spots where it didn't infill the top surface well, but other than that it looked okay. I use my Prusa Core 1. I love this printer, but you can use any printer you want. These are pretty small and easy to print. The first thing I tried to install was the 16-pin IC socket. The pin holes that they have on their board are pretty small, but this would not line up no matter what I did. When I looked at it, it was bent. All the pins were bent from shipping, so I wanted to see if these pin straighteners could straighten this out. I already showed that the one from A3D Printing Farm could straighten the pins on a new IC straight from the tube, and that worked really well, but I wondered how well it would work on a socket. Sockets by default are going to be larger than the integrated circuit that fits into them, and this thing has a wall on it that may not accept this socket. Plus, it's very loose on the rail here, so I'm not sure how straight it's going to get. So when I pushed it in, it would only go so far because it hits those walls. So this isn't going to work for a socket. It may be good for an IC straightener like they advertised, but it's not good for a socket. The squeezable one from user Phenex, which says 28-pin dip, will of course accept a 28-pin dip, and you squeeze the pins like this. And it'll actually take smaller chips than 28-pin, but will it accept the socket? Are we going to have the same problem with the walls? Well, it sure looked like it was hitting it when I flipped it over. Sure enough, it just was not getting to the pins. It was hitting the sides of the socket. Then I realized, why couldn't I just put it on the other side? The other side is flat. And this was kind of neat. So I could just slide the socket on there, squeeze it, and it should straighten the pins if this thing works right. So I did it, and it did a pretty good job. Not perfect, but it did a pretty good job of straightening those pins. Now this two-piece design from user Slothie can do both wide and thin ICs, and there's no walls, so this one might be able to do the socket as well. If you're not familiar with the wide, this is a 40-pin microcontroller. I don't use these a lot, but having something that can straighten these when I do use them is kind of handy. So when I squeeze this, let's see how straight it is. This one came out of the tube and I just put it in a drawer, so I pulled it out, and it did okay. It's not perfect. I think I'd have to do that a few more times. The 28-pin, let's try that. So I flipped it over, tried a 28-pin that came out of the tube, squeezed this one a couple times, squeezed a little harder actually in the last one, and I noticed it kind of flipped a little bit when I did that, and it did straighten the pins, but now they're on kind of an angle a little bit, so it doesn't hold it straight. So maybe that's the purpose of those walls. But when I put the socket in there, I just tried to straighten it, and it pretty much fixed everything that the other ones missed. This thing came out almost perfectly straight, and this should go right in to the circuit board. Now, like I said, the holes they use for the integrated circuits, they're a bit small, especially for a kit that someone's got to solder together, and they advertise as like a beginner solder kit. These holes should be a little bigger in this to make this easier to go in. I had to wiggle the socket a little bit because the pins aren't perfectly straight. And once I got one side in, then the other side just kind of dropped in place. And then we're good. And it actually held because those pins aren't perfectly straight. It held in place so I could flip it over and not have to worry about it falling out. So the next step was to try to put in the 8-pin socket into its location, and then I'll solder these two. Now the 8-pin wasn't as hard to do because the pins were pretty straight, and 8 pins is easier to insert than a 16-pin because there's only 8 pins to deal with. So this thing popped right in, no problem. So now it's ready to flip over and solder those pins. I am using a 6337 solder with rosin core. I don't like lead-free. It's too hard to solder. And always make sure your tip's clean. That'll make your soldering a lot easier, especially when you're doing a bunch of them like this. So this went pretty smoothly. I'd already soldered in the 8-pin. So once this is done, I can start inserting all the other components. So this is water-soluble flux, so I can clean this up with a toothbrush and water. Again, the instructions weren't great, but I was able to get all the components in place, solder them up, clip the leads. Now this thing's ready to insert the integrated circuits and power it up. The 16-pin integrated circuit looked like it had just come out of the tube. It was flared out. So I grabbed that one from Phenex, the 28-pin tool, but it fits other chips like this. And it did a beautiful job straightening those pins. And this thing pushed right into the 16-pin socket. I grabbed the same tool and used it on the 8-pin chip, which obviously came out of the tube as well. And I put that in here so it does more than 28-pin. You don't even need to put that name on there because this thing squeezed the 8-pin perfectly and it pushed right into the socket. So far, this tool is working great, and it also straightened the sockets. I found this drawer full of old ICs, and there were two 16-pin that had their legs flared out and two 8-pin that had their legs flared out like fresh out of the tube. So I'm going to use those with the other two tools. Here's the Slothie tool with a new 16-pin part. Let's see how that installs. When I tried it, it felt like it was a little wide, and after I tried to get it in the socket, it wouldn't go. So it didn't work. Next, I tried the A3D tool, and this one pushes the pins really well, and so it'll be interesting how this works. I installed it to one side and then the other side, and it pushed right in. So this tool worked really good with the 16-pin IC. Now I tried the Slothie tool with the 8-pin, and this felt really good. When I put it in the socket, it popped right in. No issues whatsoever. I just had to reposition a little bit, went right in. The A3D tool just didn't feel like it offered enough resistance. I don't know if it's just less pins on the 8-pin device, but it didn't fit the socket either. So it clearly didn't squish the pins enough. So the A3D failed on this test. Based on my simple experiment, the Phenex tool, the 28-pin dip, worked with the 8-pin and the 16-pin just fine. And it even straightened the socket. So I like this one best, even though it's probably the ugliest 3D print. This is the winner. Here's the finished design. It's got a movement sensor. It'll start spinning the LEDs as soon as you move it, and it'll stop on a number, or you can just press the button at the center and it'll do the same thing. Next step, probably make a 3D print for this. But this is where I'm going to stop for this video. But I do want to point out that I did find that somebody redrew this in Tinkercad, so you can actually simulate it and never have to build the circuit. So I'll leave a link for that in the description below if you're interested. I'm going to give a shout out to my Patreon supporters. You guys are awesome. Thank you for the support. Thanks for watching. And here's a few other videos you might like. If you want to help support the channel, Patreon's the best way to do it. And if nothing else, click on that logo and subscribe. I'll see you next time right here at Chuck Hollenbach's Electronic Products and Filament Friday.